we have the limit as x goes to infinity of the square root of quantity x squared plus 3x plus 6 and then minus x. If we try to directly evaluate this, we see we get an infinity minus infinity. So that's an indeterminate form, and we don't know what that could be. Is infinity minus infinity 0? Or is the first infinity go to infinity much quicker and so it's infinity? Or is the second infinity approach infinity more rapidly and it's a negative infinity? Or is it sort of a tie or some combination between them so it's a finite number? So we're going to try and determine this, and we're going to try to use L'Hopital's rule for help, but remember, to use L'Hopital's rule we need an indeterminate infinity over infinity or 0 over 0. We need the ratio of these in order to use the rule. So we're going to pull a couple of algebraic tricks and get it in the right form so we can use L'Hopital's rule. So the first thing we're going to do is we are going to take what's underneath the radical here, and we are going to factor an x squared out. That would leave 1 plus 3 over x plus 6 over x squared. That's still underneath the radical, and then minus x. Then we can take this x squared and bring it out in front of the radical as an x if we square root it. And we're going to do that, and then we are going to factor that x out in front that's in common in both of those terms. So we're going to bring an x out in front and then leave us with the square root of 1 plus 3 over x plus 6 over x squared, and then minus 1. Now that we have it like this, we're going to pull one more algebraic trick. We are going to let x equal 1 over t, or equivalently t equal 1 over x. So we're going to do a change of variables and express this differently, and that is so we can nicely get it in a form to use L'Hopital's rule. So the thing we have to be careful about now, if we're going to write this in terms of t, is what happens to t as x goes to infinity. And we can easily see that right here. If we took the limit as x goes to infinity of 1 over x, it would go to 0. So we need to have the limit as t goes to 0 to be equivalent to the limit as x goes to infinity. And now we replace x with 1 over t, and then we have the square root of 1 plus, so that would be 3t because t is 1 over x, and then plus 6t squared and minus 1. Now this helped us because I can now express this 1 over t could just be written down here to make it a little clearer to easily see that I now have an indeterminate form. As t goes to 0, the numerator is 1 minus 1, which is 0, and the denominator is 0. So I have the indeterminate 0 over 0, and L'Hopital's rule would apply. So now I'm going to apply L'Hopital's rule. The limit as t goes to 0, this equals, by L'Hopital's rule, the limit as t goes to 0 of, I need the derivative of the numerator, so that's going to be 1/2 1 plus 3t plus 6t squared to the negative 1/2, and we've got the chain rule multiplied by the derivative of what's inside, which is 3 plus 12t, and then that's over the derivative of the denominator, which is 1. As I look at this, I'm going to express this without negative exponents and back in radical form, just so I can easily think about taking this limit. So I'm going to have 3 plus 12t in the numerator, and the denominator is going to be 2 multiplied by the square root of the quantity 1 plus 3t plus 6t squared. Now I am ready to let t approach 0, and this would be 0, and these two would be 0, and I am left with 3 over 2.